Welcome again. In the last topic, you and I discussed some of the different types of matter that are out there. We discussed elements, compounds, and mixtures. Now that we've defined matter better and we can describe it to one another, we can now get into what chemistry is really about. Chemistry, defined, is the study of matter and the changes that it undergoes. That's really what it's all about. When we see a chemical change occur, we describe that as a chemical reaction. Let's have a look at some everyday examples to further help us define chemical changes as compared to physical changes. So imagine the kettle on the stove. You put the kettle on to boil and it gets hotter and hotter and hotter, and eventually it will start to boil. That liquid water that you've got in your kettle will change. It will turn from water as you know it into steam or water vapour. Now, clearly a change has occurred. I mean, your glass of water, that's what you need to drink, essential for your survival. Things don't work out so well if you try the same thing with steam. In fact, you can give yourself a nasty burn. So clearly the substance has changed, but it is still water. We haven't changed the chemical identity of the material. Instead, all that's happened is we've changed it from a liquid to a gas. So in brackets there, you can see I've circled it, the L for liquid and the G for gas. This is what we call a physical change, because the material has physically changed, but chemically speaking, it's still the same matter. In this case, it's still water. So a chemical change occurs when we change the identity of the matter in question from one material to another. There are lots of different chemical changes we can study. For example, I might have two distinct elements, have sodium metal and chlorine gas, and we might chemically unite them. We could join them together to make a new material, sodium chloride, your table salt. Here there's been a chemical change, and it's quite distinctive too. The sodium started off as a metallic substance, chlorine started off as a poisonous gas, but when you combine those two, we've made a completely different substance, the salt that you would put on your food. Chemical change might also be taking a material. Like in this example here, I have mercuric oxide and orange powder, and we could chemically separate the mercury and the oxide component. And we could have two elements left over. So you can now see my orange powder has turned into mercury. Mercury is an interesting element. It's one of the few metals that's a liquid at room temperature, and it's also split into oxygen gas. Once again, that gas that you and I need to breathe to live. Once again, the properties of that material have completely changed. It's undergone a chemical change. So joining elements together, breaking them apart, swapping one element for another, these are all examples of chemical changes where you change the identity of the material in question. What do chemical changes look like? Well, for an example, let's have some fun. So that there, impressive it was, is the reaction between hydrogen gas, which I had in the balloon, and oxygen gas, of which I had a small amount in the balloon and quite a lot around it as well. So the hydrogen and the oxygen chemically unite together to make a new material, to make water. This is a chemical change. So that's a visual example of a chemical change. Let's go through a couple of other examples together just to make sure that once again that you and I have the right of this, that you can differentiate between the two. The two examples we're going to look at, in the first one I'm talking about a car made of iron that is rusting. And in the second example we're looking at the process where we blend together some mixed berries and some milk or yogurt to make ourselves a smoothie. So first of all, that car is or was made of iron metal. However, during that rusting process, that iron metal changes. It turns into, well, for simplicity's sake, we can say it changes into iron oxide or something very similar to it. Oxygen from the air reacts with that iron to make a new material. If we're changing the identity of that material, it's a chemical change that's taking place. What about the other example? What about our smoothie? Then taking a whole heap of berries, pouring some milk in, blending them all together, you're absolutely changing the appearance of what you have, but chemically speaking, you still have berries and milk in that glass. You haven't changed their identity, and that means it's a physical change. Head on down to the discussion boards if you like, see if you can observe changes around you and talk about whether they're chemical or physical.